Welcome to the video for Chapter 8, Quadrilaterals, Lesson 5, Trapezoids, etc. Really, the etc. part is going to be in an additional kite video. So we're going to be answering what are some properties of other quadrilaterals. Specifically focusing on the trapezoid, the definition of the trapezoid is a quadrilateral with exactly one pair of parallel sides. There are different parts to the trapezoid, and as you guys are looking at your notes, please make sure that you have these top and bottom segments or sides of the trapezoid marked as parallel. Those are the pair of parallel sides for this trapezoid. And that's important to recognize because it's the parallel sides that are the bases. So even if I was to turn this trapezoid so that the horizontal parallel lines would now be vertical parallel lines, even though it wouldn't be on the top and bottom, they would still be considered the base. So the bases are tied to the parallel sides and the legs are the non-parallel sides. So bases are the parallel sides, the legs are the non-parallel sides. And again, we are just naming segments here. So if you labeled this one RT instead of TR, that's fine. Same thing TP, if you labeled that PT, that's fine also. So parallel sides are called the bases. The other two sides, the non-parallel sides, are called legs. Now there are 4 angles in a quadrilateral, and in the trapezoid it's the same. And so what's interesting about the idea of base angles is that you can see I've got all 4 angles are listed here. So it's like, well, if there's 4 angles in the trapezoid and they're all 4 considered base angles, what's the point of calling them base angles? And the answer really is the fact that I've paired them. P and A, angle P and angle A is a pair of base angles. T and R are the other pair of base angles. So it should be the ones that match the names of the base. So if you have a base TR, then it's angle T and angle R that are paired together. If you have base PA, then it's angle P and angle A that are paired together as base angles. Now before we get into some properties of medians and some side lengths, I want to remind you that the trapezoid, so it's not a parallelogram, there is a set of parallel sides. And so when we kind of zoom out on the trapezoid, we can take a look and see that we have parallel lines cut by a transversal. And so we can actually figure out these angles in here from the fact from chapter 4, when we learned about parallel sides cut by a transversal, the same side interior are supplementary. So as far as a generic trapezoid is concerned, we don't have any information about the angles other than that there's 360 degrees inside and 180 is over here because of the parallel lines cut by the transversal, same side interior. And so I could do the same thing over here if I were to cut with this transversal. This angle and this angle are supplementary. So of the 360 degrees, 180 is split between these two and 180 is split between these two. I don't have a special name for those because these are the base angles. My green and my blue over here, P and A, are the base angles. T and R are my other base angles, but the actual ones that are on the leg are the same side interior are going to be supplementary. So just a reminder from how that can be applied from chapter 4. Okay, let's take a look at the median of a trapezoid. The median of a trapezoid is the segment in a trapezoid that joins the midpoints of its legs. So focusing on the word midpoints, let me just go ahead and label this here with an M and a D. So this midpoint cuts TP in half, so I've labeled each of those halves congruent, and the midpoint over here, D, cuts RA in half, so these are congruent. Notice that these are using 2 tick marks and these are 1 because there's nothing saying that TP is congruent to RA. It's just that the midpoint cuts it in half, whatever it is. Now the length of this median that's connecting the midpoints together is just going to be half of the length of the bases added together. So we're going to take the length of base 1, so the top parallel, we're going to add it to the length of base 2, and then we're going to divide by 2. The version of the formula that I prefer to use is this B1 plus B2 all divided by 2. So let's take a look at this problem. We have the median. We're supposed to find the length of the median in this trapezoid. JK is 20, IL is 36, and we're trying to find MD. Well, MD is the median, so I take the bases, the lengths of the bases, I add them up and divide by 2. So that's going to be 56 divided by 2, so MD has a length of 28. Now this next one just decides to throw some algebra in here with it, and so I'm given that 6x minus 10 is the length of the median, 2x plus 2 is the length of the top base, and then 5x minus 2 is the length of the bottom base. Using the same formula, the median is equal to the sum of the bases, so I'm adding the 2x plus 2 to the 5x minus 2, and then dividing that by 2. So what I'm going to do first is just simplify some algebra here. My numerator actually just ends up being 7x because this constant of 2 and this minus 2 subtract out, so I just have 2x plus 5x, which is 7x. And then if we remember how to get rid of fractions when we're solving is to multiply both sides by the denominator. You just have to be careful doing that on the left because we do need to distribute that to be 12x minus 20 equals 7x. And then we subtract 12x from both sides. It is going to give me a negative 5, but the negative divided by the negative 20 and then divided by the negative 5 is going to give me a positive value of 4. So x equals 4, and we are done because it's just asking us to find x. We don't have to find the actual lengths of the segments. But again, the length of the median is equal to the top base plus the bottom base, all divided by 2. If you guys can set this up, just remember that I'll help you with the algebra on assessments. Within the idea of trapezoids is a specific type of trapezoid called an isosceles trapezoid. And the isosceles trapezoids, the legs and base angle pairs are congruent. What I'd like you to be thinking about is an isosceles triangle, like the Christmas tree triangle, with the top chopped off. So when you have an isosceles triangle, the base angles are congruent, but because we're chopping it off, the top off in a parallel way, the base angle pairs up top are also congruent, and these sides are congruent because of, again, of the concept of isosceles. So this fact of congruency in the base angle pairs is just going to help us, again, find some missing angle measures if we need them. So in this trapezoid, which says the measure of angle W is 73, it tells me that it's isosceles, which means that angle Z then is also going to be 73. And then I'm going to go ahead and try to use my properties of trapezoids here to figure out the other two angles. So these are parallel, and then this would be my transversal. So if I needed to find this angle in here, I could take 180 and subtract 73 to get 107. And that I'm doing this because of the concept of two parallel lines cut by a transversal and the same side interior being congruent. So I have 107 degrees here, and then again, because it is isosceles, I have 107 degrees there. So this quadrilateral Venn diagram is just a nice way to, again, visualize how all of these shapes are in relation to each other. So our very large box is the quadrilateral box because all of these shapes qualify as quadrilaterals. They have 4 sides and 4 vertices. Then we spent several lessons on the properties of parallelograms. There are 5 properties that make a parallelogram, and then within that, the rectangle, the rhombus are more specific parallelograms, and then the square is a combination of those. So if you remember, the square is the most specific type of parallelogram. Rectangles and rhombi are special parallelograms, but there are other parallelograms that are not called rectangles, squares, or rhombi. So just don't forget about those other parallelograms that would live outside of the bubbles, but inside this box. Outside of the box, we have what we talked about here in this lesson. A trapezoid is the big bubble, and then an isosceles trapezoid is a specific type of trapezoid. And then, as I mentioned at the beginning, we have this idea of a kite. That's going to come in the next little video. But we have a kite that does not qualify as a parallelogram or a trapezoid, but it is a quadrilateral, so it has its own bubble over here, and it has its own set of properties as well. So this concludes the video for lesson 5 on trapezoids, etc. What are some properties of other quadrilaterals? This video focused mainly on trapezoids, which trapezoids have only one set of parallel sides, and we call them the bases. The trapezium has no congruent sides, and you'll get the definition of trapezium in the other short video that focuses on kites, but there's also some mention of the trapezium in there. And some more information about the kite is that a kite has 2 pairs of consecutive congruent sides. And again, that will be discussed in the next video. But this kind of explains some other properties, some properties of other quadrilaterals as the lesson essential question asks for.